Myself is Kavipriya and this is Sherina. Today CMG பண்ண போறாங்க EM subjectல என்ன டாபிக்னா motion parameter, linear motion, rotary motion, relation between linear and rotary motion.
So we are going to see about motion parameters. First motion parameter, in that firstly we are going to see about linear motion. The first parameter is displacement. It is represented by S. Second parameter is velocity. It is represented by V. And the third parameter is acceleration. It is represented by A. And the fourth parameter is mass. As we all know, it is represented by kg. Next one, force is equal to m into A, Newton. Work is equal to F into S, Newton meter. Kinetic energy is equal to half mv square joule. And then the comparative, we will be comparing it with the rotary motion. Displacement in linear motion S will be represented in rotary motion as theta. Velocity V will be represented as omega. Acceleration A will be represented as alpha. Mass kg, in rotary motion it is moment of inertia. This is kg meter square, and this is a very important question in the exam perspective. Force F is equal to ma. It is represented tau is equal to I, moment of inertia, into A, acceleration, that is alpha, I into alpha. W, work, is equal to F is tau, and S, as we have seen here, it is theta, tau into theta. Kinetic energy, Ke, is half m. As we have seen here, it is represented by as a moment of inertia, and V square, it is omega square. So the SI unit of displacement, meter per second for velocity. For acceleration, it is meter per second square, and for mass kg, for force Newton, for work it is Newton meter, and for kinetic energy it is joule. For theta it is radian, for omega it is radian per second, for alpha it is radian per second square. For this it is Newton, and this is Newton meter, and kinetic energy is also Newton meter. Sorry, here too it is Newton meter. We will see the relation between linear and rotary motion. For displacement, yes, that is for linear motion S and rotary motion theta. Both will be directly proportional, that is S is directly proportional to theta. For velocity, V will be directly proportional to omega. V directly proportional to omega. And lastly, for acceleration, A will be directly proportional to alpha. So in order to remove this proportionality constant, we'll take the proportionality as R. That is, we can write it as S is equal to R theta, V is equal to R omega, A is equal to R alpha. When we equate all of these together and take R to one side, R will be equal to S by theta, which is equal to V by omega, which is equal to A by alpha. So this is the relation between linear and rotary motion, and these are the linear parameters. This is rotary motion parameters.
ஓகே டுடே டாபிக்ல வந்துட்டு மோஷன் பேராமீட்டர்ஸில் லீனியர் மோஷன் ரோட்டரி மோஷன் அதுக்குள்ளே இருக்கிற ரிலேஷன்ஸ் என்னென்னு பார்த்தோம். இதை அழகாக எக்ஸ்பிளைன் பண்ண சரி நான்
தேங்க்யூ.